Fantastic, yeah. So,
And when I was
yeah, go on, sorry.
when I was only thinking about the lighter object,
Mm-hmm.
it moved to the correct point, but the potato just didn't move.
Yeah.
It
So,
was too heavy.
yeah. So it's showing you that the weight of an object is relevant to how much you want the object to go and how much force you want to apply. Yeah.
Lav,
Mm-hmm.
do you remember when you were saying that the object is moving very quickly?
Yes.
What if you didn't know how far it was moving how far it was moving?
Yeah, but if you knew what the force that had already been applied, oh yeah, go on.
If you did, I was going to say that if you didn't know, then couldn't you use division?
Yes, you could. Oh yeah, go on. Sorry. So yeah, you could use division. How would you use the division for this formula?
So I would say that. So let's say the mass is.
Yeah.
The weight. I'm just going to say weight. The weight is. 10 kilograms.
10. Yeah.
10 kilograms.
Mhm.
And the force applied is. 23 newtons.
23.
No, not 23 newtons.
Okay.
That would be a remainder.
Okay.
50. Let's say 50 newtons.
50 newtons. Yeah.
10 divided by. No, I mean 50 divided by 10 is 5.
Yeah.
So for the acceleration.
Sorry. Yeah. Sorry. What did you say?
So I said 50 divided by 10.
When you write division sign, do you write over or do you still do it as a division symbol?
Yeah, we still do it as a division symbol. The only time we do it like this is if we're doing long division.
Oh no, sorry, I meant so like this. Do you ever have you started writing it as fraction when you're dividing? If it's no, we don't have to do it.
No.
Okay, so the only time is, did you say you use those symbols?
We've used those symbols once, but we've used them for working out.
Okay. Oh, actually, it's like this, because that's a different symbol. It's more like this, isn't it? Then you put a number here, and another number there. Is that what you've done?
You could use that to work it out.
Oh, so do you want me to use? Have you used this symbol though at school already?
Yes.
So which numbers would you put where?
I would put the 10 there.
If we call this inside and this outside.
I would put the 10 outside.
Okay.
And put the 50 inside.
Yeah.
And then this is how we learned it. We did like since it's 0, there's nothing.
Yeah.
So then we went to the ones,
Uh-huh.
with the 10s.
Yeah.
So we did 1 to 5. Oh wait, that wasn't good. So we did. Wait, that wasn't.
How many times you? I think you'd probably say how many times does 1 go into 5? Wouldn't you?
Yeah.
Yeah.
How many times? Or 5 divided by 1.
Yeah, or 5 divided by 1. Yeah. But since
Yeah.
But since it's the way of thinking about this is inside, this is outside. You know, you could say how many times can 1 go inside 5? You know.
How many times 1 goes into 5?
Yeah.
Right.
Yeah. Or, you know, like you were saying, you'd say 50
divided by 10.
Yeah.
Equals 5.
5, yeah. So you see what we've done, because we knew that already what force was, isn't it? So we took that because we have multiplication there, so in order, it's our time. It's 10 past.
So you could use the inverse
Mhm.
to find out what the acceleration is.
Yeah.
For moving.
Yeah, yeah. So then the acceleration becomes 5 meters per second per second.
Oh, it would be moving very fast, wouldn't it? If it was able to go from just in 1 second it goes 5 meters.
Oh yeah, actually, yeah, it will be moving pretty fast. But think about a car which can move 60 meters perhaps per second.
I would be going very fast.
Yeah.
I would probably be braking every even if, let's say that you were in a place that the speed limit was like really high.
Yeah.
How would you even breaking the speed limit?
I can imagine. Or even a rocket or an aeroplane, things which really move even quicker.
Yeah, if it was a rocket, I would be able to understand how it would go 60 meters per second because they would want it to go out really quickly.
Really quick.
Because if they made it slow,
Mm-hmm.
it would take really way too long even just to go to the moon.
Yeah. But then remember what we're thinking about, the force that is needed to apply in order to get that thing to move as quickly as we want it to move. So that's how we always bring back. But this is really good. You know, you are showing that you understand that in order to find out how quickly something is moving, you can actually use the division. If you knew how much it weighed and you knew how much force was already there being applied. Yes, Joe?
We're actually using maths.
Yeah, we are. Physics and maths go so well together, you will not believe it. What did you say? You are frozen.
I'll tell you once the lesson's gone.
Oh, okay. So it's a side issue. Okay. Yeah. So you know, on Wednesday we'll go through these again, but today I want you to go away and think about you've done all of this, but I want you to redo them because you did all those experiments over Easter. So I want you to, on your own, without me putting any words into what things are, I want you to go away, think about the first law, find things to do, you know, to say, if this is sitting here, then what happens? If this is moving, then what happens? Think about the second law. Perhaps with the second law of motion, I'll give you a list, or I can send you a list of things and say these things weigh so much.
Oh, yeah.
Or I would send you a list and say such and such a force were applied on something with an acceleration of something. How much did that thing weigh?
Or you could say that this much force is applied, and this is how much it weighs. So how far did it go?
Yeah, but for you, I need you to be thinking about that. What we're usually thinking about in Newton's second law is, you know, getting things moving, getting things going. How much force do we need? How much things how much do objects weigh, and how can we get them to move? Either move quicker. And then Newton's third law of motion, we talked about it. You've played with the oobleck. But then now, I want you to play around with other different things. Do you have any magnets?
We have fridge magnets.
Okay, yeah. Again, try and push them against each other so that you can feel the force in your hands.
Oh, I've done that before. I was just randomly playing around with magnetism. When I put one of the magnets facing this way,
Yeah.
the one is facing this way.
Yeah.
They were able to go together, but when they were facing the same way, they were like.
Yeah, pushing against each other. So again, that's another really good way of thinking about Newton's third law of motion: equal but opposite forces.
Well, if it was north and north, it wouldn't really. There would be the same thing.
If it was North and North, they would push apart, wouldn't they?
Yeah,
Because they
they'll
would not
push apart.
attract.
Yeah, because the force of magnetism,
Yeah.
they're going the same way. But so let's say that North was going around this way.
Yeah.
Since they're going the same way.
Yeah.
there's no
They
way
just
to
go,
actually-
yeah, like that and push because they are both, as you say, they are both sort of. Well, if North is that way, we'll just use that. So they're both going that way and managing to push against each other. But if it was perhaps different poles, North and South, one would be going that way and this one will be going more that way. And so they can,
One would be going like this.
Yeah.
and the other one- This is actually.
so they can merge together properly, yeah. Whereas this one continue to push against each other. Yeah,
So this is actually really hard to do.
I know.
Let's say that you started to do this, to turn it with your feet and then you also use your fingers. It's really hard to do because then you don't really know what you're doing.
Yeah. Okay, so we'll end the lesson here. And remember the things which I've asked you to do. I want you to go away and think about these laws in your own words, thinking about how things work. Think about the second law. I'll send you some stuff, or I'll ask your dad to just give you some stuff to do now. So that, you know, while I'm doing my job, you can then be doing. Is your dad there or is your mummy there?
Both of them.
Oh, okay.
Mommy's not working until.
Later, okay. So okay, then we'll ask your dad to help with that. And then yeah, Newton's third law. Think about it yourself. What's that? Oh, okay.
No,
Yeah.
until.
Oh, okay, yeah. And then Newton's third law, you've played around with the oobleck, but play around with other different things as well. Sit on a chair, think about what's happening. Lay on the bed, think about what's happening. Play around with the magnets, think about what's happening. Take two objects, crush them against each other, think about what's happening. Yes, Joe.
And I could also use also try and see what happens with also non-Newtonian
Fluids, yeah, as well. Yeah, which is why I say take two objects, crush them against each other. Take an egg, for example, throw it inside a bowl, see what happens. That again is still Newton's third law of motion. Then we can talk about that a bit more. Let me stop the recording.